Hello everyone, I am Dr. Sankar from SS Academy. Today we are going to demystify one of the most fundamental concepts in chemistry, the mole. While it might sound like a small burrowing animal in the world of science, it is essential bridge between microscopic and macroscopic. In this lecture, we are going to see what is Avogadro number, what is mole, and what is the relationship between Avogadro number and mole, and what is the use of mole in chemistry, and also we will discuss a example problem about mole. So what exactly is a mole? In simple terms, think of it as a counting number. Just like dozen, we know it is 12 items. One score, we know it is 20 items. One gross, it is 144 items. Similarly, one mole is 6.022 into 10 to the power of 23 items. This massive figure is known as Avogadro number. We use it to count incredibly small particles like atoms, molecules, or ions. You may think, okay, so Avogadro number means this big, huge number, which is equal to 1 mole. Why do we need in chemistry? Let us imagine you are doing a reaction with a compound A with compound B, which gives compound C. If you take 100 molecule of A and 200 molecule of B, you will get 100 molecule of C. That means all 100 molecule of A is reacted, whereas only 100 molecule of B is reacted and the remaining 100 is left. So now you understood that to know how the chemical process is happening, how the chemical reaction is happening, we need to know how many molecules of particular reactant is there. Atoms are incredibly small that we simply cannot see or weigh them individually. To give a perspective, a single drop of water contains about 1.5 times of 10 to the power of 21 molecules. Working with these giant numbers is messy and impractical. You cannot go inside to the microscopic molecules and measure how many molecules are present in given weight. It is not possible. Therefore, the mole simplifies this. Instead of talking about trillions of atoms, chemist can simply say, I have zero point 0.5 moles. It acts as a bridge, linking the mass we measure on a scale to the number of particles we need for chemical reaction. So that means if you weigh certain weight, let's say 1 gram of a compound A, and you know the molar mass of that compound, it tells you how many molecules are present in 1 gram of A. Let us look at a daily life example. Think of a baker. If a recipe calls for 24 eggs, the baker doesn't think 24. They think in terms of 2 dozen. Chemistry works the same way. If chemical recipe calls for 1.2 times 10 to the power of 24 atoms of carbon, a chemist simply thinks it is 2 moles. Now you understood you can use mole instead of big Avogadro number of molecules. But how to convert that number of molecules into mole? For that we visualize this coin analogy. Imagine if you have huge jar of coins You don't want to count them one by one. If you know the total mass of jar and that one coin weight, you can simply divide total mass by mass of one coin to find how many coins the jar has. The mole does exactly this for atoms. Now let us look at the math. The basic formula to find the number of moles represented by N is mass small m divided by molar mass capital M. Here the mass is the substance you are taking. You are taking in grams, and capital M is molar mass, which is the atomic weight you can find on the periodic table. Here the mass you are taking in the gram and molar mass given by gram per mole. So the gram cancels, it will become mole. So now it is easy for you to understand how to, if you take certain weight of the compound, if you divide that by molar mass, you will get how much mole it has. Now you indirectly calculate how many molecules are there, number of molecules are there. As you already know, if you take 1 mole of a compound, it is Avogadro number of molecule, and if you have this X number of mole, you can understand how many moles are there. Now you can also need to understand what is molar mass. Molar mass given in gram per mole. So what is this? So this means that much gram of that compound is equal to 1 mole. In other words, that much gram of that compound is having Avogadro number of molecules. So how to understand this? Let us say if you have the hydrogen molecule, what is the atomic weight of that? For one hydrogen 1, for two hydrogen it is 2. So atomic weight of this hydrogen is 2. Now the molar mass is also 2. What does it mean? If you take 2 gram of hydrogen gas, it contains Avogadro number of molecules. If you take 2 gram of hydrogen, then it is 1 mole. Let us look another example. CH4, methane. So what is the atomic weight of this CH4? For carbon 12, for hydrogen, for one hydrogen 1, 4 hydrogen 4, it is 16. So now atomic weight of this methane is 16. The molar mass of methane also 16. So that means if you take 16 gram of methane, it is 1 mole. What does it mean? If you take 16 gram of methane, it contains Avogadro number of molecules. Let us calculate mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. So regarding mole fraction, we have already published a video in our channel. I strongly recommend you to go and watch that video so that you will have a understanding about what is mole fraction. So to find out the mole fraction of ethylene glycol, you need to find out moles of ethylene glycol and solution of moles of the solution. Since the solution contains ethylene glycol and water, you need to find out moles of water also. First, we will calculate the moles of ethylene glycol. So, what is the formula for finding out moles? We have already seen in this lecture. So, N equal to mass in grams divided by molar mass gram per mole. So, we need to find out first the mass of the ethylene glycol. So, here they have given 20% of ethylene glycol. We need to find out how much mass for 20 gram of ethylene glycol. So we have 3 data. So we need to find the fourth data. So if we have 3 data, we need to find the fourth data. I have one simple technique I use for all the calculations. You can also use that. So two units are there. One is percentage, another one is gram. Let us say 100 percentage. You can consider the solution as 100 gram or 200 gram. It doesn't matter. You just write it down for our simplicity. This is 100 percentage is 100 gram solution. So now ethylene glycol is 20 percentage. So now we don't know how much the 20 percentage is equal to the weight gram. So now we have three data. We need to find the fourth one. So what we have to do always, we have to do the cross multiplication of these two, and we need to divide by the remaining third data. So what we will get, 20 percentage into 100 gram divided by 100 percentage. So 100 cancels, percentage also cancels. Unit also you can solve along with this process. So what is the remaining? Remaining is 20 gram. So we found out the moles of ethylene glycol is weight of the ethylene glycol is 20 gram. Now we need to find out the molar mass of the ethylene glycol. So the molar mass is, already I told you that gram per mole inverse. So I already discussed about what is molar mass and how the gram and mole inverse is coming. So straight away we can calculate that molar mass of the ethylene glycol. So formula for ethylene glycol is C₂H₆O₂. So atomic weight of one carbon is 12. Here we have two carbon. So therefore 24. For hydrogen 1, we have 6 hydrogen. So it is 6. For oxygen it is 16. We have 2. So 32. So if we sum this, the molar mass is 62 gram per mole inverse. So we have mass and molar mass. So just to substitute this, what is that? So mass is gram, molar mass is 62 gram per mole inverse. So gram cancels. Now 20 divided by 62, it is 3.22 mole. Now we can do same for water. So what is the mass of water? We need to find out the mass. So mass of water, we use the same technique. We have three data: percentage and weight, gram. So 100 percentage means the solution is 100 gram. So 20 percentage is ethylene glycol, means the remaining 80 percentage is water. So 80 percentage means how much gram? We don't know. That is the fourth data, we don't know. So what we have to do? Cross multiply this and divide by this. So what we will get is mass of the water in the solution is 80 percentage into 100 gram divided by 100 percentage. 100 cancels, percentage cancels. So the mass is equal to 80 gram. So now we need to find out that molar mass, which is in gram per mole. So for water, H₂O, so atomic weight of hydrogen is 1, so 2 hydrogen is there, therefore 2. For atomic weight of oxygen is 16, so the molar mass is 18. So to know the mole of water, what we have to do? Mass of hydrogen is 80, water is 80 gram divided by molar mass of hydrogen is 18 gram per mole. So gram cancels. 80 by 14 is 4.44 mole. So now you calculated the moles of ethylene glycol and moles of water. Now substitute this value in the mole fraction. You will get moles of ethylene glycol is how much? Moles of ethylene glycol is 0.322 mole. Moles of ethylene glycol and moles of water is 0.322, 4.44. Let's put a mole in outside. The mole cancels. So 3.322 divided by 0.32 plus 4.44 gives how much? It gives uh, 0.068. So this is the mole fraction of ethylene glycol, which is 20% of the solution. Thank you very much.